Welcome back to the deep dive, where we really try to cut through the noise and deliver those essential nuggets of knowledge you need. In our last deep dive, we got pretty immersed in learning and adaptation in agentic systems. Today, we're building directly on that, stepping into, well, an equally vital, maybe even more fascinating area, how we as humans actually work with these intelligent agents.
Yeah, we're talking about human-agent interaction, HAI for short. It's really the science, maybe the art, too, of designing that interface, that connection point between us and these sophisticated systems. Because, the biggest breakthroughs in AI probably aren't about replacing human intelligence. It seems much more likely they're about augmenting it, creating, well, real partnerships. And for any nation, certainly for us here, if we're committed to human-centric AI development, then getting HAI right is just critical. It ensures these powerful technologies are adopted safely, effectively, and importantly, with public trust. So yeah, it's not just about building smart agents, it's about building agents we can genuinely collaborate with.
Okay, so to help us navigate this pretty intricate landscape, we've structured today's deep dive as a comprehensive Q&A. We'll be tackling some pretty fundamental questions, things like how we interact with intelligent agents, how they learn to understand us, and crucially, how we build trust in these powerful new partners. So here's a quick roadmap of what we plan to cover. 1. How does interacting with an intelligent agent differ from using, say, a traditional software tool like a word processor? 2. What is the core design challenge when it comes to balancing the agent's autonomy with the user's need for control? 3. For this collaboration to be effective, you mentioned a shared mental model. What does that actually mean? 4. Language seems the most natural interface, right? So how does memory, which we've discussed before, make a conversational agent a better collaborator? 5. Beyond just remembering things, how can a truly advanced agent adapt to its user? 6. Why are transparency and explainability so critical for building trust between a human and an agent? 7. Can you explain the difference between those two concepts? Transparency and explainability. 8. The React framework we talked about previously seems useful for explainability. How exactly does it help there? 9. As agents get more integrated into our personal lives, the source material mentions affective computing. What is that? 10. What's the main goal of giving agents this social or emotional awareness? And, maybe more importantly, what are the risks? 11. What is the most successful and widely adopted form of human-agent collaboration today? Like right now. 12. Could you give the prime example of a Copilot and explain how it demonstrates this collaborative model? 13. Where else are we seeing this Copilot model being applied? And finally, 14. To summarize our discussion, what are the key principles and challenges we should take away regarding the future of human-agent collaboration? All right, quite a list. Let's jump right into our first question then. How does interacting with an intelligent agent differ from using something familiar, like a word processor? It sounds simple, but the shift feels pretty fundamental, doesn't it?
Oh, it's absolutely a fundamental shift. You're spot on. We're moving from what we traditionally call direct manipulation.
Right. Clicking buttons, menus.
Exactly. To something more like indirect management and conversation. With a word processor, like you said, you click save, it saves. You give explicit commands, the response is predictable.
Yeah.
But with an intelligent agent, it's different. You state a high-level goal. You might say, book me a flight to Toronto next Tuesday. Make sure I get there by 3 p.m.
Okay.
The agent then works autonomously, figuring out the steps to achieve that. So the interaction itself becomes this dynamic dialogue. You provide the intent, maybe give some feedback, and the agent gives you updates, maybe asks for clarification, reports on its progress. It's much less about pressing specific buttons and, well, more about having a conversation towards a shared objective.
That shift to conversation, yeah, it means the human isn't just the operator anymore. It's more like a dance, isn't it?
That's a good way to put it.
And in any dance, figuring out who leads when is kind of key. So that brings us to question 2. How do we choreograph that balance? The agent's autonomy versus our need for control. This sounds like a real tightrope walk for designers.
It absolutely is a tightrope walk.
Yeah.
That's the core design challenge, really. Managing that trade-off precisely. See, if an agent is too autonomous, you, the user, can quickly feel a loss of control, maybe a disconnect. You might start wondering, what is it even doing right now?
Yeah, that would be unsettling.
Definitely. But on the flip side, if you have to approve every single tiny action the agent takes, well, then you lose all the benefits of having an autonomous agent in the first place.
Right, it just becomes tedious.
Exactly. It becomes like a glorified checklist, not an intelligent assistant. So effective HAI design aims to create a kind of sliding scale of control.
A sliding scale, okay.
Yeah. So for low stakes, maybe routine tasks, the agent might be fully autonomous. It just does its thing. But for really high-stakes decisions, maybe executing a financial trade or making a critical medical recommendation, it shifts. It moves to a human-on-the-loop model.
Human on the loop.
Right. The agent proposes an action, and you, the human, confirm it before it happens. Finding that right balance is just critical for both efficiency and, importantly, user confidence.
That sliding scale sounds like a really smart way to manage the how of the interaction. But, for the agent and the human to really work as a team, they need to be on the same page about the what and the why, too. Which brings us neatly to question 3, and this concept of a shared mental model. What exactly does that mean in this context?
Yeah, the shared mental model, it's more than just mutual understanding. You can think of it as the invisible scaffolding that holds the collaboration together, especially in complex, maybe high-stakes tasks. It prevents unexpected, potentially dangerous breakdowns.
Scaffolding. I like that.
It means both the human and the agent have a clear, consistent understanding. An understanding of the task itself, the environment they're operating in, and critically, each other's capabilities and limitations.
Okay, so both ways.
Both ways. And a key goal of HEI design is actually helping you, the user, build an accurate mental model of the agent. What does it know?
No.
What are its current goals? Why is it taking certain actions? Without that shared understanding, that shared mental model, collaboration can it can quickly devolve into confusion, frustration, and ultimately the whole partnership breaks down. It really is the silent killer of effective collaboration.
That clarity is, undeniably crucial. And since language is probably our most natural way to interact, our 4th question looks at memory. We touched on this before, but how does memory make a conversational agent a better collaborator? How does that fit in?
Right. This connects directly back to our earlier discussions on agentic systems and learning. Memory is what transforms a, let's say, basic stateless chatbot.
Like the early ones.
Exactly. Into a coherent, genuinely valuable conversational partner. And we're really talking about 2 key types of memory here. First, there's what we call working memory. That's essentially the agent's immediate context window.
Okay.
This is what allows it to follow the flow of the current conversation, understand pronouns, referring back to something earlier, handle interactions that span multiple turns. I mean, imagine talking to something that couldn't remember what you just said 2 sentences ago.
Hopeless.
Utterly useless. So that's working memory. Then there's episodic memory. This often involves long-term storage and uses techniques like retrieval augmented generation, VARG.
RG, we've talked about that.
Yes. RG essentially lets the agent pull specific, relevant information from a vast external knowledge base when it needs it. And this episodic memory is what enables the agent to remember past conversations, recall your specific preferences, maybe details about you, and build a kind of persistent relationship over time.
So it learns about you.
Precisely. An agent that remembers a project you worked on together last week and can just pick up where you left off. That's a true collaborator. That's not just a tool anymore.
That distinction between working and episodic memory really helps clarify how these agents can become, genuinely useful partners. Which leads us right into question 5. Beyond just remembering facts, how can a truly advanced agent adapt to its user? This feels like the next step, personalization.
Yes, adaptation is definitely beyond just recall. It's about genuine personalization and even a bit of foresight. An effective conversational partner doesn't just remember things about you, it actively adapts to you.
How so?
Well, this involves learning your preferences. Things like your unique communication style. Are you formal, informal? Your level of expertise in a certain domain, does it need to explain jargon or not, and your specific goals in the interaction.
Yeah.
It then takes all that and tailors its responses and suggestions accordingly.
Okay, tailoring is key.
It is. And even more advanced is what we call proactive assistance. A truly sophisticated agent doesn't just sit there waiting for your next command.
Right.
Based on its memory, its understanding of your goals, it can actually offer suggestions before you ask. For instance, imagine an agent helping you with research. It might notice your reading history and say something like, hey, based on the last 3 papers you looked at, I found a new article on a related topic. Looks interesting. Would you like me to summarize it for you?
Wow, that would be helpful.
Exactly. That kind of predictive, helpful interaction, that anticipation, that's what really distinguishes an advanced agent from a simple tool.
That's a definite game changer, moving from just reactive to genuinely proactive. Okay, let's pivot now to something absolutely crucial for any partnership, human or otherwise. Trust. Question 6. Why are transparency and explainability so critical for building trust between a human and an agent? It just feels foundational.
It is the bedrock.
Right.
Absolutely. And to connect this to the bigger picture, we simply will not hand over significant control to or meaningfully collaborate with systems we don't fundamentally trust.
Makes sense.
Trust isn't some optional feature you add on later. It is the absolute cornerstone of human-agent interaction. And just like in any human relationship, it has to be earned. And it's built primarily on that solid foundation of both transparency and explainability. These two elements give you, the user, the confidence to rely on the agent, to understand its actions, and just to feel secure in the partnership. Without them, even the most technically brilliant agent will really struggle to gain widespread adoption, let alone public confidence. The real nugget here, maybe, is that in the AI world, trust isn't just about whether it works reliably. It's about the human feeling that the agent's intentions are aligned with theirs.
Ah, the intention part.
Yes. Even when they can't directly see the why behind every action. And that feeling is, well, much more fragile and complex than trusting a traditional tool like a hammer or even a word processor.
That's a really powerful point about the unique nature of trust with AI, and it leads perfectly into our 7th question. Can you maybe clarify the difference between those two concepts, transparency and explainability? They sound similar, but clearly they have distinct meanings here.
Yes, they sound related, and they are, but they address two very different, though complementary questions. Think of it like this. Transparency answers the question, what are you doing right now?
Okay, the what?
Exactly. It's about providing clear visibility into the agent's current state and its ongoing actions. So a well-designed agent interface should give you a real-time view. What's its current task? What subtasks is it working on? Maybe even what specific tools or APIs is it using to get the job done? This lets you monitor progress and understand its behavior in the moment.
Got it. So what about explainability?
Explainability, on the other hand, answers the question, why did you do that? Or maybe, why did you make that specific decision?
Why?
The why. It's also known as explainable AI or XAI. It's the agent's ability to articulate the reasoning behind its decisions or recommendations. And this, frankly, is a major challenge, especially for systems based on deep learning, which, as you know, are often called black boxes.
Right, the black box problem.
Precisely because their internal decision-making process can be so opaque, even to their creators sometimes. So transparency is what? Explainability is why.
That distinction is incredibly helpful. What versus why? And speaking of explainability, our 8th question connects back to something we've covered before, the REACT framework. Reason Act. It seems potentially useful for explainability. How exactly does it help?
Yes, the REACT framework with its explicit thought, action, observation loop is indeed a very powerful tool for building explainability into agents.
How does it work in practice?
Well, by exposing its internal monologue, its thoughts, the agent is effectively showing its work. It's laying out its reasoning process. You, the user, can literally follow its chain of reasoning step by step as it processes information, considers options, and decides on actions.
So you see the logic.
You see the logic unfold.
Yeah.
And this is absolutely crucial for building user confidence, especially when the agent is making critical decisions. If an agent recommends, say, a complex medical treatment or a major financial investment,
Yeah, you'd want to know why.
you absolutely need to understand why it reached that conclusion. A well-designed agent using REACT should ideally be able to answer follow-up questions like, why did you choose that action instead of the alternative? Or what specific information led you to that conclusion? This doesn't just build trust, it also makes debugging much easier when things go wrong. It's fundamentally about demystifying that black box.
It really is about opening up that black box, isn't it? Okay, let's shift slightly. As agents become even more integrated into our personal lives, sometimes blurring the lines between tools and, well, companions, our 9th question comes up. The source material mentions affective computing. What exactly is that?
Affective computing. It's a fascinating and rapidly developing field within AI. It's dedicated to enabling systems to recognize, interpret, and sometimes even simulate human emotions.
Simulate emotions, wow.
Well, perhaps respond appropriately to is better than simulate. An agent with effective computing capabilities could, for instance, analyze your tone of voice if it can hear you, or maybe your facial expression if it has camera access, or even just your specific word choices in text to try and infer your emotional state. Is the user frustrated, excited, confused?
And then what?
Once it recognizes or infers that emotion, it could then adapt its own communication style in response. So if it detects you're getting frustrated, the agent might adopt a more patient, perhaps more supportive tone, or it might offer to simplify its explanation or try a different approach. It's fundamentally about understanding the human emotional landscape to interact more effectively within it.
That sounds like a capability that could really transform how we interact with technology. But wow, it also raises some pretty profound ethical questions, doesn't it?
Absolutely.
So our 10th question gets right to that. What is the main goal of giving agents this social or emotional awareness? And crucially, what are the risks involved?
Yeah, this is where we need to be really careful and thoughtful. The goal, let's be clear, is not to create deceptive AI that tries to fake emotion or manipulate users. That would be deeply unethical.
Right. That's important.
The real goal is to build agents that can interact more naturally, according to established human social norms. The idea is to make the interaction significantly more pleasant, less jarring, and ultimately more effective. Think about, say, an educational agent that could detect when a student is maybe losing focus or feeling discouraged, and then offer some timely encouragement.
Okay, that sounds positive.
Or perhaps a healthcare companion agent that could respond with calming reassurance if it detects anxiety in a patient's voice. These are potentially significant benefits.
But the risks.
But the risks are substantial, and this field is definitely fraught with ethical challenges. Designers have to be incredibly careful to avoid any form of manipulation, and they need to manage user expectations very, very clearly about the agent's true nature. It's still software. We absolutely need to avoid situations where users start projecting genuine human emotions or consciousness onto these systems. It's a very, very delicate balance to strike.
That delicate balance is absolutely clear. Okay, let's shift gears a bit, moving towards applications. Question 11. What is the most successful and widely adopted form of human-agent collaboration that we're seeing today?
Well, I think without much doubt, the most successful and certainly the most widely adopted form of human-agent collaboration right now is the Copilot model.
The Copilot.
Yes. A Copilot is essentially an AI agent that works directly alongside a human user, usually embedded within a specific application they're already using. Its role isn't to take over, but to act as an intelligent assistant. It's designed to augment your skills and significantly accelerate your workflow. It's really an efficiency multiplier rather than a replacement.
The Copilot model. Yeah, it seems brilliant in its sort of simplicity and effectiveness. So question 12, can you give us the classic example of a Copilot and maybe explain how it really demonstrates this collaborative model in action?
Sure. The quintessential example, and you could argue the one that really pioneered this space, is GitHub Copilot.
Right, for coding.
Exactly. It's an AI agent integrated directly into a programmer's code editor, the environment where they work all day. As the human developer writes code, GitHub Copilot is constantly observing the context, not just the line they're typing, but the whole project. And it proactively suggests things. It might suggest the next line of code, or sometimes entire blocks or functions.
So it's not writing the whole thing.
No, absolutely not. It doesn't write the whole program autonomously. Instead, it acts like a pair programmer, an AI pair programmer. It's great at handling repetitive boilerplate code, suggesting solutions to common programming problems, and it drastically reduces the cognitive load on the human developer. But crucially, the human remains firmly in control. They review the suggestions, they can accept them, reject them, edit them. The AI acts as this incredibly efficient thought partner, freeing up the human to focus on the higher level design, the complex problem solving, the creativity. It's really a perfect illustration of augmentation.
That's a fantastic example of augmentation, not replacement. Okay, so question 13 then. Where else are we seeing this Copilot model starting to be applied? It feels like it's spreading pretty rapidly beyond just the world of coding.
Oh, absolutely. This Copilot paradigm is being integrated into a huge range of tools and applications across many different industries now.
Well,
Take, for instance, Microsoft 365 Copilot.
right, in Office apps.
Exactly. This agent can do things like summarize long email threads for you, draft reports in Word based on just a simple prompt, or even help create PowerPoint presentations from a document outline. Or think about creative tools, design tools, like Adobe Firefly. Here, an AI agent can generate images from text descriptions, it can extend the background of a photo seamlessly, or create variations on a design theme. Again, working as a creative partner to a human designer. In all these examples, the real power of the Copilot approach is that it keeps the human firmly in the driver's seat. You provide the high-level intent, the creative spark, the critical judgment,
human input.
the essential human input, while the AI Copilot handles the more tedious, maybe repetitive or data-intensive aspects of the task. It's just a really powerful demonstration of how AI can truly augment, rather than replace, human expertise and creativity.
This has been an incredibly insightful deep dive, really fascinating. So to bring it all together now, our final question, number 14. What are the key principles and maybe the key challenges we should take away from this discussion regarding the future of human-agent collaboration?
Okay, summarizing this, I think the first key takeaway is that the ultimate success of this whole agentic AI revolution won't just be measured by the raw intelligence of the agents themselves. It's going to be measured by the quality of the interactions they have with us, the humans.
Right, the interaction quality.
Yeah.
Exactly. And achieving that quality requires that fundamental shift we talked about, moving away from simple direct command towards a more nuanced conversational style of collaboration. For this partnership to truly flourish, agents need to be equipped with both robust memory working and episodic and genuine adaptability. That allows them to be consistent, personalized, and ideally proactive companions. We also established that the absolute bedrock of this entire relationship is trust, and that trust has to be painstakingly built through radical transparency, understanding what the agent is doing, and genuine explainability, understanding why it's doing it.
Transparency and explainability, crucial.
Absolutely crucial. And as we venture into these more personal domains, touching on social and emotional interaction through things like affective computing, we have to tread incredibly carefully. We need to constantly balance the potential utility with unwavering ethical integrity, making sure we avoid manipulation, and clearly manage user expectations. The rise of Copilot tools like GitHub Copilot and others offers a really powerful and, I think, promising model for the future. It shows a path where AI acts as a true force multiplier for human creativity and productivity. So ultimately, the goal of human-agent interaction, the whole field, is to design not just intelligent tools, but genuinely trustworthy collaborators. Collaborators that can really help us tackle the world's most complex challenges together.
What a compelling vision for the future. You know, this raises a really interesting question for me. As these agents become even more sophisticated, even more integrated into our daily lives, how might our own definition of collaboration start to evolve? Especially when one of the partners in that collaboration is an advanced AI. What new forms of collective intelligence might actually emerge when humans and agents truly start to merge their distinct capabilities? It's definitely a fascinating thought to chew on. Our journey into agentic AI is far from over. Please be sure to tune in for our next deep dive. We'll be tackling the absolutely critical topics of safety, alignment, and ethics in agentic AI. Thank you so much for diving deep with us today. If you found this discussion valuable, and we hope you did, please subscribe to our channel, Tech AI and Beyond. That way, you won't miss any of our future explorations into the future of technology.